your test?
No, I didn't. I'll do that after class.
Okay. I think I have all the rest. So I'll give you your scores later today. And Luke and Brian, I did get a document from you also, and then I saw the answers typed in on the Google Classroom. I erased them from there though, so. Yep. But it was funny because Luke was like, "No, I didn't copy off of Brian." You guys are so good because we did have one answer different, Luke. So I think that's
yeah, we did.
That's kind of neat. You guys are always honest. Okay, your homework was on that geometric mean, and then if we have a right triangle and we draw an altitude to the hypotenuse, we create 3 triangles, really. We create 2 more, 3 total, and they're all similar to each other. Kind of cool. So you had to do 1 to 4, which was on geometric mean, and on that similarity statement. So number 1, Brian, what did you get?
2 root 30.
For number 1?
Yes.
Did you multiply 5 times 20?
Wait, I'm looking at it right. Hold on. 10.
10.
Wait, which page was this on?
That was on 569.
Okay.
Number 1. Brian, did you change it?
What?
What did you say for number 1?
I had said 2 root 30, but now I realize it's 10.
Okay, 10. Yep. 10 is correct. Number 2, Grace?
12.
3, Colby?
I got sorry. Root 24. Wait, sorry, I'm not speaking very well. 2 root 24.
Okay, you could simplify root 24 because that's 4 times 6. But I still don't think we've come out with the correct answer. Luke, what did you get for number 3?
10 root 6.
10 root 6. Okay, is that where you got the 10 root 6 from, Brian?
Like
40 times 15 is 600. Okay, Colby? So we're going to do 100 times 6 or 10 root 6.
Yeah.
Okay, and number 4 is the similarity statement. So they show us they show us the triangle, and we have to write the similarity statement. Aristotle, what did you get for that?
Triangle ECB is similar to triangle CFD is similar to triangle EFC.
Yes, that works. Now, you may not have your letters in the exact same order that Aristotle just said them. That's okay. If your triangle ECD is CDE, then you just have to say, is my other one FDC and FCE? Okay? So this is a correct similarity statement, but look at that and see if you wrote yours differently, if it still is correct. Okay, as long as you keep those same angles in the right spot with the same angles. Okay, you guys had some more questions on geometric mean. Numbers 8 through 13 were geometric mean. Is that what I gave you? Let me look at this. Yep, 8 through 17. Okay, 8, Lily, what do you have for 8?
I have 18.
9. Aristotle.
20.
Mm-hmm. 10, Brian.
10 root 5.
Mm-hmm. 11, Colby.
I got root I keep saying this wrong. 8 root 6.
It's 12 root 6. I think. So I'm going to look at this. 36 times 24 is 864, which is 144 times 6. So the square root of 144 is 12. So we'll have 12 root 6. Okay. And Grace, number 12.
I think I got this wrong, but I said 2 root 14.4.
14.4. I'm going to look at this one too. A 12 times 2.4 is 28.8. The answer they're giving me is like really weird. So for 28.8, I would probably just take the square root of that and round it to 5.4. Say it's approximately equal to 5.4. The other answer the book is giving is 12 root 5 over 5.
Yeah, that's what I got on my
That's right.
calculator.
Oh, really?
Yeah.
Okay, so that would be fine. Or 5.4 if you say approximately equal to. And number 13, Lily.
3 root 3.
Yes, good. Okay, that's root 27, which is 3 root 3. All right. The next is a bunch of similarity statements. Not my favorite thing to do. This is one of the things that hurts Mrs. Palmer's brain a little bit. But it is this section, so let's see what we're doing for 14. Luke, what do you got?
Okay, these always confuse me, so I'll just try some. So triangle ONM is similar to triangle OLN
Yes.
is similar to MNL.
ONM, OLN. The last one should be NLM.
Oh, yeah.
Okay, so something like that, but you might not have it in that order, but just make sure you keep all the letters corresponding the same way. All right, number 15, Brian.
I said triangle XYZ was similar to triangle WXY, which is similar to WXZ.
All right, I'm just writing it down. I'm going to check it. You started with XYZ, XYZ, WXY, WXZ, WXZ, XYZ. Those ones are good. That middle one. XYZ. WY. That middle one should be WYX. XYZ. No, XYZ, WYX, WXZ. Here, the second one. All right, Colby, the next one. Number 16.
I have RTS. Well, triangle RTS is congruent to triangle RTQ, which is congruent to triangle QRS.
All right, so it's that one in the middle again. Should be QTR. QTR, so the big one. RTS is similar to QTR, is similar to QRS.
Okay.
Okay, and Grace, the last one.
Triangle FGH. Or would it be? Is similar to FGI. And I said it's similar to HGI, but I don't think that's.
Okay. So if I go with the first one you give me, Grace, and so we keep it that way, FGH, that's the big one, right? Do you see G is the right angle?
Yep.
So when you're doing triangle fig, the bigger triangle that you've made, you want to make sure that you put I in the same spot where G was, because I is the right angle in my new triangle. So I and G have to go in the same spot, and they share angle F, so that stays in the same spot. So the bigger triangle that you create is FIG. Okay, and then we're going to look at the smaller triangle. So I want to put my right triangle in the same spot as G. So it's going to go in the middle. And they share angle H. H. So for my original was H. So G goes in the same spot as my right triangle. HG, FGH, FIG, GIH for the last one. Okay, so you want to have I as your right triangle. They share H, and we put G in the other spot.
Okay.
Okay. Those definitely hurt our brains. Okay, there's another theorem in this chapter. So I'm going to try to share with you again and go through the video. So let me hook us up. Present, right? My screen. Whole thing. Okay.
All right, let's take a look at some more information with that altitude drawn to the hypotenuse. You'll see I've labeled the altitude H, and I've labeled the two sections X and Y.
Oops.
Let's go 5 and 20. This one's going to be tough. ED, and that is if the altitude we had X and Y. The reason I want to do that is the altitude is going to be the geometric mean of the two sections that are created. Okay, so remember just a minute ago, we had X equals the square root of that 5 times 10. Well, since we don't know what these are right now, this is going to be H equals the square root of the product of the two sides that we just formed. The reason I didn't label those CD and DA is because that would get a little bit confusing underneath that square root bracket. And this is also how the book does it as well. So H, which is the altitude, is the geometric mean of X and Y.
That's pretty cool, right?
And so, you know, just using the example we did before, actually we did 5 times 20, but I'm going to do 5 times 10. If that was 5 and that was 10, and they wanted you to find the altitude, then that would simply be the altitude is equal to the square root of 50. We know that that's going to break down into the square root of 25 times the square root of 2. So that altitude we can find is 5 square roots of 2. And that's using the side lengths of 5 and 10. Okay, so let's step on to Theorem 8-3. Okay, Theorem 8-3. And then I believe we're going to wrap it up and see a good example of that. All right, this is a crazy little creation. Notice that the angles are in capital letters and the sides are in lowercase letters, and they correspond to the opposite. I want to do okay. B. The opposite side is B. C. The opposite angle is C. Come on, make a little circle. There we go. And then angle A is opposite side A. Okay. Still have the little pieces X and Y. So now we're going to be finding A and C. Okay. We're going to be finding A and C. Okay. So A is going to be our geometric mean. Let's make sure I'm on a black pen here. A is going to be the geometric mean of the segment that it is adjacent to, which is X, times the entire segment that's opposite, which is B. And that means C will be the geometric mean of the segment it is adjacent to, which is Y, times the entire segment, which is B. Again, when I'm looking at side A, the adjacent side is, I don't like that. I want that to be bigger. The adjacent side to A is side X, and the adjacent side to C is side Y. Just a quick reminder, adjacent stands for next to. Okay. And so in the next example, I'm going to attach some numbers to that. So let's go ahead and look at the final example. We're going to wrap it all up, put it all together. Okay, what we're going to do is we're going to combine all of those theorems, and we are going to solve for X, we're going to solve for Y, and we're going to solve for Z. So using those theorems in the examples before, if you think you can find X, Y, and Z, go ahead and hit pause and work through it, and then we'll see if we are correct at the end.
All right, guys, what do you think? All right, so if we're trying to find X, right here, we're going to say that X equals the square root of this adjacent side, 5, right, times this side, 20. So if X is the square root of 5 times 20, what would X equal? Colby, what's 5 times 20?
100.
Good.
So
Square root of 100
10
is going to be 10.
Oh wait, yeah, just 10.
10.
Sorry.
Just 10. All right. So if X is 10, all right. Well, if X is 10, this is going to be kind of easy now because now we can use Pythagorean theorem. Right? If this is 10, yeah. All right, Pythagorean theorem. So we could do 20 squared, 400, plus 10 squared, 100. That's 500. So Z is square root of 500. 5 root 10.
Yeah.
Okay. So Z will be 5 root 10. I don't know if he's going to do it that way. We have another right triangle. This is 5. This is 10. And we're trying to find our hypotenuse. Right? 10 squared plus 5 squared. So that's 100 plus 25. Square root of 25.
5.
Sorry, square root of 125. Sorry. Square root of 125 would be 25 times 6, or 5 root 6. Let's see. Let's see how they do it. They might use the theorem for all of them.
Okay, so what I'm going to look at first is I'm going to look at x. I notice that it's an altitude, and it is drawn to that opposite hypotenuse. So the theorem that I'm going to use is not the keyboard theorem. The theorem that I'm going to use is this one, Theorem 8-2. Remember that the altitude is the geometric mean between the two pieces that have been created. So in this case, the two pieces that have been created are the 5 and the 20. So x is congruent to the square root of 5 times 20. This kind of looks familiar. I believe this was the example that I did. Obviously, the square root of 5 times the square root of 20 is the square root of 100. So x equals 10. I'm going to clean it up and put it over here. Okay, x equals 10. Okay, because y is a leg, then we're going to use theorem 8-3. Notice how I would compare y to side A in this case. And A was the geometric mean between the adjacent side and the entire side. So let's go back and look what we have. So y is going to be the geometric mean of the adjacent side, okay, which is 5, times the entire side, which is going to be 25. Okay, so the adjacent side of 5 and the entire side, which is 25. So that's going to equal the square root of 125.
Right, so they're doing that a different way than the Pythagorean theorem, but we still had the square root of 125 when we did it.
And in this case, we're going to go ahead and find out what the square root of 125 is. We're going to round that to the nearest tenth. And I will fast forward here, and that's going to be approximately 11.2. Okay, so do the Pythagorean theorem to find side z. But I think using the geometric mean is just a little bit easier. And so to find z, we're going to find its adjacent side, which was 20. And we're going to multiply that by the entire side, which was 25. Okay, so 25 times 20, that's going to give me 22.4. Now, very important to look at this right triangle and make sure that those values make sense. Obviously, z could not be greater than 25 because 25 is the hypotenuse. So 22.4, that makes pretty good sense, and that sounds about correct. Okay, so x equals 10, y equals 11.2, and z equals 22.4. That is example number 3.
All right, guys, what do you think? Okay. All right, so we're gonna work on some of these. That is on in your Google Classroom if you need to go back when you're doing your homework and like review those theorems. What I'm gonna have you do page 569. It goes on to page 570. And there'll be problems like this, 5 through 7 and 18 to 23.
What is it, 18?
5 through 7 and 18 to 23.
What page?
569 and 570. And you guys can pop in between 2 to 3 if you have questions, or you can email me. And Lily, also don't forget to email your tests to me or share your document with me. Okay? Lily, also your SumDog, were you able to log in yet?
No, my Wi-Fi has been slow, but it's working today, so I'll do it.
Okay. All right, sounds good. Okay, guys, have a great day.
Okay.
Bye.
Bye.
Yeah.
Thank you.
You're welcome. Have a good day.